So before we start working on problems, I want to do a quick crash course on quadratics. So the first concept you need to know is axis of symmetry. So there's basically a formula for the axis of symmetry that is negative b over 2a. And what this tells us is, as the name would imply, when we graph out quadratics, they always look like a parabola, as I'm sure you've seen before in your math class. So they look something like this. And they're always symmetrical. So you see how the left side is the same as the right side? Like you could draw this axis of symmetry through the middle of the quadratic. And what that basically is, it's like a mirror. So whatever's to the left of that will mirror the right. So if you plug in the negative b over 2a of the quadratic, that'll tell us what point the axis of symmetry occurs at. And the b and the a, for those that don't know, this just comes from ax squared plus bx plus c. This is the standard form of a quadratic, so we just plug these numbers into here. So that's axis of symmetry. So the next thing you really need to know is vertex form. So let me write that out, vertex form. Okay, so this is basically the quadratics that are written in the form y equals a times x minus h squared plus k. And this is a formula that's really useful because it lets us know where the vertex is. So if I were to graph this parabola, it'll look something like the last one. And all parabolas, they have a vertex. And this occurs at h comma k. So if I had real numbers plugged into that, I could easily find what those are. So a key thing to note is like this h here is positive, but if it was negative, it would actually be plus h. So like an example is like if it was x plus 3 inside, the vertex would be at minus 3. So that's one thing to keep in mind. But yeah, that's pretty much how you do these. It's pretty straightforward. Make sure you know this formula. Pops up a lot on the SAT. And then the last thing I think you need to know with quadratics is factoring. So quadratics are often written in the form of like, let's say x squared plus 5x plus 6. And then you need to know how to turn this into x plus 3 times x plus 2. I broke it down into its factors. The way I did this is I looked, okay, what multiplies to give me 6 adds to give me 5? And that's going to be 3 and 2. This takes a little practice, but that's really all you have to do to factor this. If you know everything that I showed you on screen here, you'll be pretty set on how to do the quadratics that show up on the SAT. And now we're going to get into some practice problems. Okay, so on screen here, I wanted to start you guys out with an easy one. So we have this function h of x equals x squared minus 3. And you can see it's a quadratic given by the x squared. And what we want to do is just find which of these tables corresponds to h of x. So all we have to do is just plug in the values in the tables and see which one matches up. So let's start out by plugging in h of 1. So when we do that, we'll get h of 1 equals, that'll be 1 squared minus 3, which is just going to be 1 minus 3, which is negative 2. So now we can just cross out any of the choices that don't have negative 2 for h of x. So we can cross out this a, and we can cross out the c. So we're already down to a 50-50 chance, not bad. So then now, let's plug in, we don't need to plug in 2 because b and d have the same thing for that. So we just have to plug in a 3. So when we do that, we'll have h of 3 equals 3 squared minus 3 equals 9 minus 3, which is going to be 6. So as you can see here, B is going to be the answer. So this one's pretty easy, but I just wanted to give you guys a warm-up, just showing how to like plug the numbers into these. Now we'll get into some of the harder ones. So in this next problem, we have this equation, negative 4x squared minus 7x equals negative 36. So when we're given one like this, what you have to do is you want to get all the terms on one side and set it equal to 0. This is typically how quadratic equation solving is done. We always want to set it equal to 0 and then find where it crosses the x-axis. So now we have it in the standard quadratic form. So what I'm going to do now is I'm going to pull up Desmos And I'm going to just type this in and then see where it crosses the x-axis, because basically what's going to happen is we're going to have some parabola. It's going to look something like this, and it's going to cross the x-axis at 2 different points. The question asks for the positive solution, so wherever it crosses, we'll just take that. You could solve this using either the quadratic formula. I'll write that on screen here. It's negative b plus or minus square root of b squared minus 4ac over 2a. I went off screen a little, but we're not going to use it, so it doesn't matter. You can either solve it using that, or you can factor and solve it. But on the SAT, I would recommend always, if you can, to Desmos it out, because it just saves a lot of time. So I'm going to pull up my Desmos window, and I'll show you how it's done. So here in Desmos, I'm going to type in the new equation. So that'll be negative 4x squared minus 7x plus 36. So I'll zoom out a little bit so you can see it better. So we have this parabola, and just like my sketch, you can see that it goes up to some point and then it goes down, and it crosses the x-axis at 2 different points, negative 4 and 2.25. So they asked for the positive solution, so that'll be 2.25. So then if we go back to our here to our answers, 2.25, well, that's just going to be the same thing as 9 over 4. So that's going to be our answer B. And as you see, Desmos makes things a whole lot easier. So with this question on screen here, we're asked to find the minimum of f of x, so the x value, where it reaches its minimum. So basically what's going to happen here is we have this parabola, f of x equals x minus 10 times x plus 13. And what's going to happen is I'm going to draw it out. It's going to do something like, it's going to look something like this. And it's going to have some minimum point, and we're asked to find that minimum point. So there's 2 ways you can do this. You can either do it like I did in the last one, where you just plug it into Desmos and you just click on the bottom and find that minimum point. I'm going to actually work it out this time just to show you guys how it's done, because I think this one's actually easier to just do it yourself, because you can do it in like 2 seconds. So the way you want to do this is whenever you want to find the minimum, that's really the same thing as the axis of symmetry. So the formula for that is just negative b over 2a. So all you have to do is just FOIL it out and then just plug it into that formula and you're good. So what you're going to do is you're going to FOIL the x minus 10 times x plus 13. So first outer inner last, let me write it again down here so I can help you visualize it. So what you're going to do is you're just going to multiply the x times the x. So that's going to be x squared. You're going to multiply x times 13. That's going to be 13x. You're going to multiply negative 10 times x, which is going to be negative 10x. And then you're going to multiply negative 10 and 13, which is going to be minus 130. And then as you can see here, these can combine. So this is really just x squared plus 3x, and then minus 130. And then the negative b over 2a formula is, and I that went off screen a little, but the minus 130 is honestly not needed, so I'm not going to worry about that. And then really for the negative b over 2a formula, you're just going to take this 3, that's your b, and this 1 in front of the x, there's an imaginary 1 here, you could think of that. That's your a. So the answer to the question is going to be, let me change colors and move up here. The answer is going to be negative b over 2a, which is going to be negative 3 over 2. And as you can see here, that's going to be d. So you can either do it the Desmos way. I didn't show the Desmos way because I think it's really just typing how they give it in, and then you would click on it. And we already did a Desmos example. Or you just FOIL and then plug in the axis of symmetry formula. That axis of symmetry formula, it's really important. I highly recommend having that memorized. And yeah, if you have any questions, just leave it in the comments. So this problem on screen is more of a word problem. It's more like you got to think about the context not do math so much, but I'm going to show you guys the underlying math and how to think through this. So we have this function. It's dealing with a ball's height above the ground in inches, and then they tell us that x is the amount of seconds since it's been dropped, and it's on the range 0 to 10. And then basically what we need to find is what is the interpretation of the vertex. So like, what does the vertex mean in this context? So let me just draw it out, what's kind of going on here. We have this parabola. It ranges from 0 to 10. And then this is time on the, so let me label that. This is time, and then this is height over here. So we have time and height, and then it has a positive a value, so we know it's going to open up. So it's going to look something like this. The parabola is written in vertex form. That means when it has like that, it's like in a parentheses, x minus something squared, and then plus a value at the end. Basically, the let me underline this. X minus 7 we use to find the x value of the vertice, and this 3 is our y value of the vertice. So the vertex is just going to be 7, 3. So it's the opposite of the like minus 7 is going to be positive 7, and then it's just going to be the 3. So I'm going to label that here. It's going to be at 7, 3. That's the minimum of the minimum point. So what that basically means is that at 7 seconds, the ball is at its minimum height. Okay, that's what that means. And then using that info, we can pretty much answer the question because we're just asking to interpret the vertex. So A says the metal ball's minimum height was 3 inches above the ground. I mean, yeah, that looks to me like the answer. So I'm going to put that, I'm going to circle it. That looks right to me. But I'm going to go through all the choices and just kind of walk through them, make sure we didn't miss anything. B says the metal ball's minimum height was 7 inches above the ground. So no, the 7 in this context means the minimum occurs at 7 seconds after the ball is dropped. So no, that is not going to be the answer. C says the metal ball's height was 3 inches above the ground when it started moving. No, when it started moving over here, you can see it's going to be somewhere up here. So that's not going to be the answer. So C clearly cannot be the answer. And then D, the metal ball's height was 7 inches above the ground when it started moving. Again, no. The 7 in this context is in the x dimension, which is dealing with time, so it can't be D. So this question, while it may look intimidating, may look like a lot of reading and math, it's really not. You just have to understand how vertex form works, and then it's pretty easy from there. So this is the last question I'm going to go over. This one's pretty easy, but I just want to cover this one. This deals with factoring. I'm going to write that in big letters. It may not be obvious at first, but this is really just a factoring question and just understanding if you understand how to use it in context. So we have this equation, d minus 30 times d plus 30 minus 7 equals negative 7. So the first thing you should do here is add the 7 over to the other side. The reason I knew to do that was because, well, if I add the 7, it'll make the other side 0. And then when you're dealing with quadratics, you always want it to be 0. So let's do that. So you add the 7 over, and then those will cancel, and then you're left with d minus 30 times d plus 30 equals 0. And then now what you have to recognize is this is really just a quadratic in factored form already. And then they were nice enough to factor it for us, honestly. And then when you have that and it equals 0, you can just split each factor up and set it equal to 0. So when you solve for that, you'll get d equals 30. And then when you solve for this one, you get d plus 30 equals 0. D equals negative 30. So this question is an open-ended one, so you can just answer either 30 or negative 30. So it may look intimidating, but this one is really not that bad. Thank you guys so much for making it all the way to the end of the video. If you like this video, make sure to smash that like button down below and subscribe. On screen, I'm showing you how to register with our tutoring site, mvplearners.com. If you still need more SAT help after the video, please reach out to us. We'll be happy to help you. We offer SAT lessons for only $40 a lesson. You're not going to find a better rate, so go sign up now.